Welcome to the deep dive.
Great to be here.
So today we're doing something a bit different. We're diving into cybersecurity using a specific set of materials.
Yeah, we've got these practice questions and the explanations that go with them for the NetSec-Pro exam.
Right. And we thought instead of just exam prep, these questions are actually really useful,
Yeah.
like little windows into key ideas in network security today.
Exactly. Things like next-gen firewalls, cloud security, how they actually work.
Our mission then is to sort of unpack what these sources tell us about keeping networks safe. Identifying apps, users, catching tricky threats, managing it all.
It's a good way to see the practical side.
Okay, so let's dive in. But first, maybe just a quick note on the exam itself. The source mentions a few basics.
Sure. The material says it's web-based, online proctored, 90 minutes,
Okay.
costs $200. You need an 860 score to pass, and it's delivered in English.
So that just gives you a feel for the context it's aimed at, testing, practical technical skills.
Right. Not just theory.
Okay, good context. So let's get into the meat of it. First up, this idea of application identification. The source material brings up a question about how modern firewalls identify apps, especially ones that are, let's say, behaving unexpectedly.
Yeah, like using non-standard ports or even encrypted traffic. That's a big challenge for older firewalls.
So what's the tech the source points to?
It points directly to something called App ID. The key thing the source emphasizes is that App ID figures out what the application is based on the traffic itself.
Not just the port number.
Exactly, not just the port or the IP address. It looks deeper at the characteristics of the traffic, even if it's encrypted or hopping ports.
And that's crucial because...
Well, because apps today are slippery, right? They don't always play by the old rules.
Right.
App ID is about basing security on the actual application, not just network addresses. It gives you back that visibility.
Makes sense. Okay, moving from apps to the people using them. Identity. The source material talks about Prisma Access and something called the Cloud Identity Engine.
Right. It asks about its functions within that cloud security setup.
So this engine, its job is basically connecting to where user identities are stored, like Active Directory or...
Precisely. It acts as a bridge to your various identity providers, and the source specifically calls out two functions.
Which are?
First, cross-platform user authentication, so verifying users no matter what device they're on or where they're connecting from.
Okay.
And second, user group mapping from multiple directories, pulling group information from different sources to apply policies consistently.
So for you listening, if you're dealing with users scattered everywhere, using different devices, maybe with identity info in different systems, this engine helps tie it all together for security policy.
Yeah, it's about consistent identity-based control in a modern, dispersed environment.
Okay. Now let's shift to detecting threats,
Mhm.
specifically the nasty stuff, the advanced malware. The source brings up a tool called Wildfire.
Ah, Wildfire.
That sounds energetic.
Yeah.
What's its main role, according to the material?
Its primary function, as the source describes it, is to analyze unknown files. Files the firewall hasn't seen before and doesn't have a signature for.
And how does it analyze them?
It uses sandboxing. Basically, it runs the file in a safe, controlled virtual environment and watches what it does.
Okay. Like a detonation chamber for potentially bad software.
Exactly. Does it try to make weird network connections, modify critical system files, that kind of thing? It's key for catching zero-day threats that traditional signatures would miss.
Got it. Very important for new threats. Now, sticking with the theme of users being everywhere, remote user connectivity. The source asks about securing mobile users connecting into Prisma Access.
Right. How do you securely connect those users who are, out and about?
Is it just a standard VPN or?
Well, the source specifically points to the mobile user gateway as the component responsible.
Mobile user gateway, okay, and its job is?
Its function is to be that secure entry point for remote users into Prisma Access. It manages their connection, authenticates them, and crucially applies the cloud security policies to their traffic.
So it extends that secure corporate bubble right out to the user's laptop, wherever they might be.
Pretty much. And it's not just individual users. What about whole remote offices? The sources also touch on onboarding remote networks into Prisma Access.
Like branch offices connecting to the cloud security service.
Yeah, and there's a specific step highlighted that you have to do before adding the remote network in the management tool, Strata Cloud Manager.
Oh, a prerequisite.
Yes. The source says you need to allocate bandwidth per location first.
Ah, planning ahead. So you have to decide how much capacity each remote site needs before you configure the connection itself.
Exactly. It points to the fact that deploying this stuff isn't just clicking buttons, there's infrastructure planning involved. Resource allocation.
Makes sense. Need to plan for the traffic load. Okay, so once everything's connected and traffic is flowing, you need to see what's happening, especially threat-wise. How does an admin view alerts, say from advanced threat prevention?
According to the source material, that's done via the threat logs.
In Strata Cloud Manager again?
Yes, within the same management interface. Those logs show the alerts, give you details about the detected threat, source, destination, all the info you need to investigate.
Okay, so that's the central dashboard for threat visibility and response.
Right.
Fundamental stuff.
Now, here's a really interesting and sometimes contentious topic the sources bring up: traffic decryption.
Ah, yes. SLTLS inspection.
Right. The material asks about the purpose of configuring a decryption policy rule on a next-gen firewall.
Why would you want to decrypt traffic? Isn't encryption good?
It is good for privacy, absolutely. But that's the problem from a security perspective. The source explains that if traffic is encrypted, the firewall can't see inside it.
So threats could be hiding in there.
Exactly. Malware, command and control traffic, data exfiltration. It could all be hidden inside legitimate-looking SSL or TLS sessions. The primary purpose of the decryption policy, according to the source, is to allow the firewall to inspect that encrypted traffic and apply security controls, like threat prevention or data filtering.
So you temporarily decrypt, inspect, and then re-encrypt.
Essentially, yes. It's about regaining visibility into that otherwise opaque traffic stream. It's a critical capability, though it does come with performance and privacy considerations, of course.
A necessary capability, though, it sounds like. Now, managing all these policies, app ID, decryption, threat prevention, across maybe dozens or hundreds of firewalls. That sounds like a headache.
It would be. Which is why the sources bring up centralized management, specifically mentioning Panorama.
Okay, Panorama. What's its key function?
The source identifies its role as managing many firewalls from one place. Specifically, it mentions managing policy configurations and template stacks.
Template stack?
Yeah, think of them as predefined configuration settings, including network settings and policies that you can apply consistently across multiple firewalls. Panorama lets you manage these templates and push them out.
Ah, so it ensures consistency and saves a huge amount of time compared to configuring each box individually. Reduces errors, too, I bet.
Definitely. Big efficiency and consistency benefits, especially at scale.
Okay, going back to connecting remote sites, those branch offices we mentioned, the sources ask about the types of tunnels supported for connecting remote networks to Prisma Access.
Right. For those site-to-site connections, the material lists two specific types,
Yeah.
GRE and IPsec.
Okay, standard tunneling protocols. So you use one of those to build a secure, encrypted path from the branch office router or firewall up to the Prisma Access service.
Correct. That allows traffic from the remote network to be securely sent to the cloud for inspection and policy enforcement.
Got it. One last piece here, security profiles. The source asks about a key benefit of using these within a firewall policy rule.
Security profiles. Yeah. These are things like antivirus, anti-spyware, vulnerability protection profiles.
So what's the main benefit of applying them to a rule?
The key benefit highlighted is that it enables threat detection and prevention for allowed traffic.
Okay. So just because you have a rule saying allow web browsing, that doesn't mean the job is done.
Exactly. The policy rule might allow the connection based on source, destination, application, user, but the security profile attached to that rule then inspects the content flowing through that allowed connection for threats.
So it's an extra layer of scrutiny, even on traffic you've decided to permit. Checks inside the flow.
Precisely. It adds content-level inspection on top of access control.
As everything moves more towards cloud and encryption becomes even more pervasive, how does this constant need for really deep inspection and fine-grained dynamic control keep pushing the boundaries? How does it challenge how we design, implement, and manage security going forward?
That's definitely something to think about. Where does that evolution take us next?
Indeed. Thanks for diving in with us today.